All right, hey guys. So we're gonna go ahead and get started. So today is our last review day. So we're gonna go over those last couple units that we did, just kind of quick summary review some of the concepts, the equations, things like that. So there's no Friday assignment tomorrow. Your Friday assignment is pretty much, if you owe me work, get it done. We have to get stuff done very quickly. Next week, we have to get grades submitted. So the sooner you get some of that stuff made up, the sooner it goes in. Remember, I don't want to see any of you guys at summer school with me. I got enough people. I don't need any more. So I want everyone to pass and get all their stuff taken care of, but I can't do that part for you. So remember, second period, your exam is on Monday. So it will open right around what our normal live class time would be. It'll be open at 9:10. You'll have the whole period you can work on it. It's 50 multiple choice questions. So you should have no problem finishing it during the period. The only thing you're allowed to use on the exam is the reference sheet and the calculator. And that goes for everybody. My guys at home will have cameras on and stuff. So that's Monday. Tuesday is the third period exam. And then Miss Kincaid's fourth period is here in this too. Y'all's exam is on Wednesday. Same deal. It will be set to open about 10 minutes into the class period. You'll have the whole period to finish it. You should have no problem getting that done and taken care of. All right, so I was waiting on a couple people to get in. I think we have most everybody now. So our last couple units we focused on, so we went through reactions yesterday. So I kind of put mole and stoichiometry together because there's so much crossover between them. And then we're going to do a quick review of the acids, bases, and everything. So with mole and stoichiometry, remember we had certain conversion factors that we could use. So we had for gases, we had that 1 mole was equal to the 22.4 liters. Remember that value is on the front of your reference sheet. The front page, that very first table, it's at the bottom of that first table. 1 mole is also equal to the molar mass of whatever that substance is. So remember, molar mass we get from adding the masses on the periodic table together. 1 mole is also equal to Avogadro's number of particles. That's that 6.02 times 10 to the 23rd particles. Remember, that number is also on your reference sheet. That's the very first thing on the first page, is Avogadro's number. Whenever we got into stoichiometry, we added that mole to mole conversion. So whenever you're changing from moles of one substance into moles of another, that's where you can use those coefficients from your balanced reaction as your mole ratio. That was kind of the most common misstep that I noticed whenever I was grading that test. A lot of people would forget that mole ratio. And remember, you need to cancel out your units. So make sure whatever you're trying to cancel goes on the bottom of the next step. So with mole, we also went a little bit further, looking at our individual formulas. and we looked at the percent composition, empirical, and molecular formulas. So remember, percent composition looks at what percentage of a compound is a certain element. This is based off of the percent by mass. So remember, to find percent composition, we did the element mass divided by the compound mass times 100 to make it a percentage. Sometimes it asks you for the percent composition of a certain element. Sometimes it asks you for the percent composition of the whole compound. If it asks you for the percentage for the whole compound, that's where you have to do this for every element in the compound. Most people did okay with percent composition. What threw some people was the empirical formulas. So remember, empirical formula is kind of the reverse of percent composition, where instead of having the formula and finding the percentage, a lot of times you're given the percentage and you're trying to find the formula. So remember, an empirical formula, and I didn't click on my pen, it's that reduced formula. So it's going to be that lowest whole number ratio formula where the subscripts are not divisible by the same number. So the steps for finding an empirical formula was that poem, the percent to mass, mass to mole, divide by small, multiply till whole. So remember, to go from percent to mass, we just change the percent sign to grams, but leave the number the same. To change from mass to mole, that's our one-step conversion, using molar mass to change from mass to mole. Once you have moles for everything in the substance, whatever that smallest value is, you divide everything by that number. And if for some reason that number ends up not being a whole number, because those numbers, remember, are going to be your subscripts of your formula, that's when we will need to multiply till whole. And if you multiply one substance, you need to multiply everything. So numbers that you would need to multiply to make whole would be things that are pretty nice even numbers. So something like 0.25 or 0.5 or 0.75, where you would multiply by like 2 or 4 to get it to be a whole number. Also, it could be like the thirds, so like the 0.33 or 0.66, where you can multiply by 3 to make it a whole number. You shouldn't be needing to multiply by like 27 or something like that. That's crazy. Then we had the molecular formulas. So remember, molecular formulas are the kind of actual formula. These don't have to be reduced. These can be whole number multiples of that empirical formula. So whenever we were trying to find the molecular formula, a lot of times they'll give us the molecular mass or molar mass of the substance. So we do the molar mass that they give us divided by the mass of our empirical formula. That gives us a whole number. That ratio gives us a whole number. That tells us what number we need to multiply all of our subscripts by to get our molecular formula. And then, so we have the same, we kind of have to give the same exam for general versus honors. So limiting reagents is not on your exam. Everybody say yay, no limiting reagents. I know some people are happy about that. But we will have percent yield. So percent yield, remember, looked at how much we made in a lab setting versus how much we should have been able to make mathematically. So percent yield, we do the actual divided by the theoretical times 100. So remember, your actual is your lab value. So this tends to be given of how much was produced in the lab or how much was obtained or found, whereas your theoretical is your calculated value from your stoichiometry problem. So whenever you do stoichiometry, you're finding theoretical yield, and that number goes on the bottom whenever we're finding percent yield. All right. And then we got into our last unit that was the solutions, acids, and bases. So let's look at the solutions part first. So with solutions, we have two parts of a solution. We have the solvent and the solute. Remember, the solvent is going to be the substance doing the dissolving. So a lot of times this is referred to as our dissolving medium. So a lot of our solutions are aqueous solutions. So remember, in aqueous solutions, our solvent is water. That's what we're dissolving everything in. Whereas the solute is the substance being dissolved. So it's what we put in the water to be dissolved. Whenever we're looking at how much can dissolve, we're going to talk about saturation. So remember, saturation, something can be saturated, unsaturated, or supersaturated. So remember, unsaturated means it dissolves less than it should be able to. So when we were looking at solubility curves, remember the unsaturated values are below whatever the line is for that particular substance. If a solution is saturated, that means it's dissolved all it should be able to. That means it's going to be on the line for that particular substance. And then supersaturated, remember, means that we heated it, made it dissolve more than it should be able to. So it will crystallize whenever cooled. So this will be above the line on those solubility curves. So speaking of solubility curves, you will have questions where you have to read this, but kind of like it has been in the past, it will give you the solubility curve, ask you questions about it. It may give you a different solubility curve other than this, but it will be the same format. So it still has how many grams can be dissolved in 100 grams of water. So remember, anytime it says 100 grams of water, kind of ignore that. That's just talking about the unit. And then it has temperature across the bottom. Remember, each curve, each line is a different substance. So you guys have kind of seen all the questions that could be asked about this. It might say how much of ammonium chloride can dissolve at 60 degrees Celsius. We'd say, okay, well, 60 Ammonium chloride is NH4Cl. That's between 50 and 60, so I'd probably say about 55 grams. Or it might ask, what temperature will we be able to dissolve 90 grams of potassium nitrate? Well, 90 grams potassium nitrate is the KNO3 right here. Go down, and that temperature is about 55 degrees. So those were pretty straightforward. Remember, it could also ask you if it's saturated, unsaturated, or supersaturated based off of this. So remember, that will give you both values and want to know where that point on the graph is in comparison to the line for that system. So say that we have, let's do 60 grams of KCl at, let's do 70 degrees. Okay, 70 degrees, 60 grams is right here. Now we said we're looking at KCl. So here's the line for KCl. That point of 70 degrees and 60 grams is above the line for KCl. So this would be a supersaturated solution. So that's one where it'll start to cool and it will crystallize. So remember, you're looking at where is that point in comparison to the line. Above it is supersaturated. If this was at 70, if it was like 45 grams, that's pretty much on the line. So that would be saturated. If it was below the line, it would be unsaturated. I think everyone felt pretty comfortable with the solubility curve. Calculations we did with solutions are, we found that molarity. So remember, concentration looks at how many grams are dissolved in a certain volume. Molarity is specifically one of our formulas we do. So remember, molarity is moles over liters. Most people did okay with those calculations. Some things that I noticed is sometimes it may give you grams. You cannot plug in grams. You have to change into moles before plugging in. I also had some people where it gave you milliliters and they forgot to change to liters before plugging in. But overall, people did pretty well with those type of calculations. And then some people had issues with dilutions because they forgot that they were two different things. So remember, dilution is where whenever we order chemicals, we might get like a 6 molar acid. Well, that can kind of burn your skin. So I'm not going to give that to you guys. I'm going to dilute it and make it less harmful for you guys. So remember, dilution is that NV equals MV. So that beginning molarity times volume is equal to the final molarity times volume. Because remember, in dilutions, we're not changing the number of moles. We're just adding water to it, which is changing the volume and effectively changing the molarity. So if you only have one of each variable, either molarity, liters, or moles, it's a molarity problem. If you have 2 volumes or 2 molarities, it's a dilution problem. So I had some people trying to plug the dilution values into molarity and it got all mixed up. So make sure that you're kind of careful about that. But they are 2 separate calculations. And remember, both of those are on your reference sheet. All right, then we went into the acids and bases part of the unit. So this was kind of our last thing we finished up with. Acids and bases. Pretty much the big thing we talked about were like the properties of acids and bases was what we started out with. So property-wise, we looked at taste first. So remember, acids tend to have a sour taste. These are things like lemons, grapefruits, vinegar, things like that. Bases have more of a bitter taste. So these would be things like milk is slightly basic. Dark chocolate is basic. So that's where dark chocolate can have that bitter taste. Most bases are hazardous to taste. So remember, a lot of times our like cleaners and stuff will be basic. Well, we don't want to taste those. We talked about with acids, we talked about them being electrolytes. And bases, certain bases can be considered electrolytes as well, but we see a little bit more with acids. So remember, electrolytes we talked about were things that produce ions, therefore they can conduct electricity. So these are those ionic compounds that can conduct electricity, are electrolytes. So with acids, because they split into like the hydrogen and then whatever anion, and all of those are floating around in solution, electricity can flow through those ions. That's where we talked about like Gatorade, Powerade, stuff like that, that has electrolytes. It will conduct electricity. Don't try it at home, but it will. With bases, we talked about, because a lot of our cleaners are bases and stuff, they have that slippery feel. So that's where we said if you've ever like cleaned the tub or your sink or anything like that, you kind of have that like greasy residue. Or if you put a lot of cleaner and then like try to step into the tub, it's very slippery. You can slip. With these, we also looked at, they change color with indicators. So we did kind of our indicator lab, and we saw that there were multiple indicators that could change color. The indicators we were focused on, though, with acids and bases that you need to know are the litmus paper. So remember, those are the little like pH strips. With acids, they're going to turn more of a red color, so it might be like orange to red. With bases, the pH strips are going to turn blue. So it'll kind of fade from like green into blue for those more basic substances. Our other indicator we need to know is the phenolphthalein. So phenolphthalein was one of those that we had to drop into it. This is one that we said they used to detect blood on crime shows and stuff. For acids, phenolphthalein is going to be clear or colorless. So you're not going to notice a change with acids. But whenever you get to bases, they turn that like hot pink fuchsia color. So remember, that reacts with our blood because our blood is basic. So that's how they can find the presence of blood. We also talked about with these, anytime you mix an acid plus a base together, it's always going to produce some form of salt and water. So remember, you guys just took the test on it, so it should be pretty recent, but it might say like which of the following are properties of acids, or which of these is a property of a base. So that should be not too terrible. Okay. And I'm going slightly out of order. So we already talked about electrolytes. A lot of times, since these produce ions in solution, they can conduct electricity. One of the last things we did in the unit was we talked about the different types of acids and bases. So remember, we had our Arrhenius definition of acids and bases. These are our normal acid-base definitions. So this is where acids produce hydrogen ions. In water. So acids start with hydrogen and they produce hydrogen, whereas bases produced hydroxide in water. So here bases had to have hydroxide according to the Arrhenius definition. Then we got into our Bronsted-Lowry acids and bases. Remember, these kind of branched out and included more things that maybe don't necessarily start with hydrogen or don't have hydroxide that could be acidic or bases. So remember, acids are going to donate hydrogen ions. So they still give off hydrogen ions, but they don't necessarily have to start with hydrogen. Hydrogen could be elsewhere in the formula. And then bases accept that hydrogen ion. So that's where we said acids lose hydrogens, bases gain hydrogens from one side of the reaction to the other. And remember, that's where we had like the acid that loses a hydrogen. After it loses the hydrogen, it becomes the conjugate base on the other side of the reaction. The base that's going to gain a hydrogen, after it gains the hydrogen, it becomes our conjugate acid on that product side. So those two you may have to identify. The third type of acid base, we kind of just did the definition. And so Lewis focused more on what's happening with the electrons versus what's happening with the hydrogens or protons. And his rules are kind of the opposite of normal. So normally acids give off something. Here, acids are going to accept an electron pair, which will form a covalent bond. The base is going to be donating that electron pair. Which forms that covalent bond. So those we didn't have to identify. Those are going to be more of our like larger organic substances, but they could still be acidic or basic. And then in between those, we already kind of talked about indicators changing color with different pHs. Remember, we kind of had to know the litmus and the phenolphthalein. If it asks you about any other type of indicator, it will give you an indicator chart to refer to. That might give you like the pH range where it changes color. It might tell you the colors it changes. But they're not going to ask you about any other indicators other than litmus or phenolphthalein without giving you some extra information to use. So don't worry about like memorizing an indicator chart or anything like that. Then we did our acid-base calculations. So remember, all of these formulas are on your reference sheet. And we had formulas that would let us go between pH, H+, POH, and OH negative. So these, it was just kind of figuring out which equation you needed to use. So remember, if we're going from the ion to pH, so hydrogen to pH, that was the pH formula, the negative log of H+. Remember, do not forget that negative sign. That's one of the most common things where people make math errors. Same thing could be said if we have hydroxide and we're going to POH. It's the same formula, just for OH instead of H. So that's the negative log of OH. If we're going the opposite direction, say that we have pH and we want the ion, these are those formulas that are at the bottom of your formula list. So to find hydrogen, we do the antilog. We do the 10 to the negative pH. And yet again, do not forget that negative sign. I had some people set this up and then they left it. They didn't give me an answer. They didn't actually punch in the calculator. So make sure I actually punch in the calculator to see what it gives you. Same thing if we are going from POH to OH negative, it's the same formula. It's the antilog, but it's to the negative POH. We also had a formula that let us go between pH and POH. That was the pH plus POH equals 14. And then we also had that KW formula that let us go between the hydrogen ion and hydroxide ion concentration. So that was that hydrogen times hydroxide equals 1.0 times 10 to the negative 14th. So remember, those came in handy. And where some people lost points is they would forget to address like the whole question. So like it would give you H plus and want POH. Well, you found pH, but then you didn't go to POH. So you didn't do all that it was asking you to do. So kind of be careful of that and make sure that you do end up with the correct substance, the correct value that you're looking for. All of those were pretty straightforward. It's just kind of plug in, solve for X, but make sure that you're using the correct formula. That's what people were coming across. So that is everything officially in a nutshell. So remember, the cumulative tests are kind of like final tests. It will have a mix of stuff from every single unit. So you kind of know which units you struggled on more than others. Remember, the review is posted. You can go through, do some practice, especially if you had trouble with a certain area, practice that certain area. I do have the answer key to the review posted. So that's something where you're like, I just don't remember how to draw dot structures at all. There's a section in bonding where you draw dot structures, do the shape, geometry, all of that jazz. Try it, check your answer on the key. Make sure that you feel comfortable with that stuff. So that's up. There are those crash courses that are up. They're kind of like one page of here's everything from the mole that you needed to know. So those are up as well. You know, just utilize your time of what you can do. So the test is 50 multiple choice questions. You should be able to finish within your given class period, unless there's some other circumstance that's going on, but we'll kind of play with that on an individual basis. Remember, grades, we do have to submit them next week. So like I said, if you are missing any work, that needs to get taken care of as soon as possible. If you're going to do that homework replacement, you can do that to get that taken care of. Remember that your homework and labs are together. So if you have a lab grade that's lower than any of your homework grades, you can replace a lab with it. That's perfectly fine. Remember, there's the remediations for reaction, mole, and stoichiometry. Remember that if you made less than a 60, that can get you up to a 60, or it can add 5 points to your score, whatever is going to be better for you. So some of you guys that got like a 75 on something, you can get it up to the 80. Utilize your time wisely. So you guys have about I'd say about 25 minutes left of live time and then 25 minutes left of class. Use it wisely, do what you need to. I'll stay logged on for my guys at home that come across any questions. But other than that, you guys have a good weekend. And I will catch you back on Monday.